At high magnification, the familiar greenery of a suburban lawn disappears. Shrink down to the size of an ant, and your backyard reveals itself as a landscape of jagged jaws and predators armed with flesh-melting venom. The Florida predatory stink bug is one of these specialists. While its relatives use straw-like mouthparts to drink plant sap, this insect is a hunter that targets the pests eating your garden. Those vibrant, contrasting colors serve as a biological warning label. If a predator ignores the signal, its first defense is a discharge of noxious, foul-smelling chemicals. This defensive spray is coupled with an offensive weapon, a piercing beak that delivers a sharp and highly painful venomous bite. These bugs employ cytotoxic venom. This cell-destroying enzyme floods their prey, liquefying the internal organs into a slurry. Once dissolved, the stink bug uses its mouthparts like a vacuum, suctioning out the liquid and leaving behind an empty exoskeleton. Beneath the garden canopy, these colorful hunters rely on internal digestion to regulate pest populations and maintain the balance of the ecosystem. Moving from the leaves down to the bark and debris, the hunting strategy shifts from active pursuit to absolute stillness and deception. This is a lacewing larva. To get close to its prey, it constructs a physical backpack of fungus and plant debris, transforming into a moving piece of lichen that aphids never see coming. Its relative, the owlfly larva, uses a different disguise. Its body is flattened and spiked to blend perfectly into tree bark, where it waits with massive jaws that act like hollow needles to deliver paralyzing venom. Lower still, in the sandy topsoil, camouflage is replaced by the active engineering of the environment. These crater-like pits are the work of the antlion. Each one is a precision-engineered trap designed to catch insects foraging on the surface. When an ant steps over the edge, the antlion flicks sand particles from the bottom of the pit. This creates miniature avalanches that pull the struggling victim directly into the center of the trap. This is a high-risk hunt. Many ants are venomous themselves, so the antlion must use its curved jaws to deliver an instant, paralyzing strike before its prey has a chance to fight back. Life on the forest floor is dictated by these high-stakes interactions, requiring specific architecture and fast-acting toxins to neutralize dangerous targets. In the damp leaf litter, we find the firefly larva. Long before it takes flight as a beetle, it lives as a heavily armored predator that hunts through the soil. It specializes in hunting the invasive hammerhead flatworm, a creature that protects itself with a slime containing some of the world's most potent toxic poisons. The firefly larva subdues the worm with its own venom, then harvests the flatworm's chemicals. It ingeniously repurposes these stolen toxins to fuel the brilliant bioluminescent light it will eventually use as an adult. In this environment, toxins function as a critical resource, harvested by the firefly to fuel its development and survival across its various life stages. Submerging into the local pond reveals a different arena, where hunters weaponize liquid physics to find their next meal. The water scorpion mimics a floating reed or stick to remain invisible. It stays submerged for long periods by using a breathing tube like a snorkel while it waits for small fish to swim within reach. These predators rely on surface tension, the elastic film created by water chemistry. When an insect falls into the water and struggles, it sends out vibrations across this film that act like a sensory web. The backswimmer monitors these signals from the underside. By swimming inverted against the surface layer, it can track the precise location of a struggling victim before launching its venomous attack. Along the sandy shoreline, the toadbug uses a warty appearance to blend into the wet ground. It watches for landing insects, then pounces to deliver a dose of cytotoxic venom. From the surface film to the sandy edge, these predators use the physical properties of water to detect and dissolve their prey in a 360-degree battlefield. While their methods are violent, these hunters are not a threat to humans. They function as biological control agents, regulating the insect populations that would otherwise overwhelm the local environment. For a small invertebrate, venom is the functional tool that overcomes the physical limitations of size, allowing a tiny hunter to take down much larger prey. But insects aren't the only forgotten venomous creatures lurking in our backyards. There is an entire world of spiders hiding in the shadows with their own toxic secrets. Look closer at your backyard wilderness, and you'll find an ecosystem more complex than it appears. To see what's lurking in the dark corners of the garden, subscribe and join us for the next discovery.